in this example, we're going to be trying to compute a confidence interval for a mean with sigma unknown. So let's read the question first. It says that a random sample of 37 U.S. colleges had a mean tuition of $17,952 per year with a standard deviation of $9,381 per year. Find a 95% confidence interval for the mean tuition of all U.S. colleges. So looking at this problem, we know that we're trying to compute a confidence interval. And we're trying to predict a mean because it explicitly asks for the mean tuition of all U.S. colleges. But the question is, how do we know whether or not this standard deviation that's given right here, is that supposed to be sigma or s? So this is the first question we need to ask. Is the standard deviation sigma, the population standard deviation, or is it s? And in this case, we just can tell that it's s, the standard deviation of the sample, based on context clues. And this is really a language question more than a math question. How is our reading comprehension? So if we look at it, it says a random sample of 37 U.S. colleges had a mean tuition of $17,952 per year with a standard deviation of 9,381. So when we look at that standard deviation, that 9,381, the question is that referring to just those 37 schools in the sample, or is that referring to all U.S. colleges? And based on the way that this one's phrased, it's clear it's talking about those 37 U.S. colleges with a mean tuition of 17,952 and a standard deviation of 9,381. So in this case, it turns out that we have S. So let's go through our procedure. The first step that we're going to do is compute our point estimate, but the point estimate's given in this problem, so we want our point estimate. Which is x bar, and in this problem that number is explicitly given. It's the 17,952. So we have our first step. We're 20% of the way there. Second step, we need to compute the critical value. And the critical value, again, if you'll recall in our 5-step process, it's based on the confidence level, which, looking at this problem, is 95%, specified right here, as well as the degrees of freedom. And you'll have to remember, for our formula from before, is that the degrees of freedom is going to be the sample size minus 1. So in this case, our sample size is right up here. It's 37. And if we subtract 1 from that, we'll get 36 for our degrees of freedom. So we want to compute, in this case, the next thing that we're going to compute is our critical value. If I can write here, there we go. It is t sub alpha over 2. We know it's t because we're using s. We're using s rather than sigma, which tells us we must be using a t distribution on this one. And so we need to figure out what this is. And to do that, we're going to have to go back and look at the table. We know the degrees of freedom for this problem, we just said it a minute ago, is going to be 37 minus 1, which is 36. So I need to go look at row 36 in my table A3. So let's scroll over to that. Here again is table A3. We are looking at the degrees of freedom right here. And as we go through it, here is the row that we need to use, 36. That was our degrees of freedom. And the confidence interval, likewise, was 95%. So 95% confidence level, degrees of freedom equal to 36. Recall that that's how the column here is labeled, degrees of freedom. So 36, 95, 36. What number is sitting right at the intersection of those two? It is right there, 2.028. So that's the number that we'll go back and use. So this number right here is 2.028. And again, that is based on the 95% confidence level and the degrees of freedom, which is 36. So that's the number we'll use going forward. So the next step is to come back and compute our standard error. And that is simply s over the square root of n. And so for us, s is the standard deviation of the sample. It's given in the problem. It's 9,381. And we need to divide that by the square root of the sample size. It's important to note here that means we're going to be using the 37. We do not use the 36. We don't use the degrees of freedom here. We use the actual value of n. And if we plug this into our calculator, let me take a minute to do that. I get, let's see here, I got about $1,542 $1.23 ballpark. So there's our standard error. Now we compute our margin of error. And the margin of error is just the result of step 2 times the result of step 3. So I just need to multiply together to get my value of m. Let's move this up just a little bit. To get my value of m, it's going to be equal to t sub alpha over 2 times s over the square root of n. We already computed these values. So t sub alpha over 2 is 2.028, and I'm multiplying that by the result of this s over the square root of n. That's this $1,500 that we just found. So I multiply that by 1542.23, and out of this we get approximately $3,127 and about 64 cents. So we found our margin of error. The last step is to put all these pieces together, and that's what we'll do here to compute the actual confidence interval. I just need to add this number that we just computed, this 3,127, to our point estimate, which is x bar. So x bar plus and or minus this margin of error m that we just found. So for us, our confidence interval is two numbers. The first number is going to be our point estimate, which is 17,952. So 17,952 minus the margin of error that we just found, which is 3,127.64, and up to 17,952 plus 3,127.64. And so if I go into the calculator and carry out this subtraction and this addition to get my two numbers, the numbers that I wind up with are, I get at the low end, and again remember these are in terms of dollars, this is cost of tuition, so the low end is $14,824. And again, I'm getting these numbers just off the calculator, and 36 cents if we really care about pennies here, up to $21,079.64. So the result of all of this is that we are 95% confident, based on our sample, that the true mean tuition of U.S. colleges is between $14,124, this lower number, and $21,079, this high number. And we can do this exact same thing on the calculator. So this was doing it by hand. On the calculator we can do the exact same problem. We need to go to our list of tests. So to do that we hit the Stat button, go to Tests. Again, this is a confidence interval, but we're using a t-distribution rather than a normal distribution, so the selection we're going to take here is t-interval. So if we select t-interval, it'll allow us to enter all of the data that's given in the problem. The first thing it'll ask for is the mean. So again, it'll ask which form of input we want to use. In this case, we're wanting to use statistics because the statistics have already been computed. We've got in the problem the mean and standard deviation are already specified, so we have the statistics we need. So I'm going to select statistics or stats in the calculator. I'm going to give it the value of x bar, which in this case is 17,952. It'll ask for Sx, the standard deviation, that's the 9,381. It'll ask for our sample size, which in this case was 37. It'll ask for the C level or confidence level, which is 95%, 0.95. And if we hit calculate, it will give us, rounded to the nearest dollar, it will give us 14,824. At the low end, and again that is units of dollars, and at the high end 2180. So $21,080. So there are our results. You can see that they agree with the results that we computed by hand if we round to the nearest dollar.